everybody, my name's Tessa and I'm here with Jakub, Yo, and Moulshree to present our South Chicago Master Plan. Before we begin our technical analysis, let's evaluate the existing conditions for the proposed site. So we see here a map of our population density. North of the site is Chicago proper, where the population density is the highest. As you move away from downtown Chicago towards the proposed site, the population becomes less dense. We also assess the economic vibrancy and diversity of the area. Here we see a breakdown for the ethnic diversity, and the area has mostly African American and Hispanic population. The area was also found to be less economically prosperous, have a reduced accessibility from limited rail lines, and pose greater instances of crime than other areas in the Chicago region. So here's the context for the site within a roughly 2-meter radius. There existed a few existing parks, a rail line that connects it to Chicago, some schools and some hospitals, but most everything was a bit removed from the area, so we need to build up a lot within the proposed site. On the whole, we found that the area was a lot less vibrant than desired. However, this gives us an opportunity to fully revamp the area. So due to the initial limited accessibility of the region, we sought to create a fully self-sustaining area where people could work, eat, and play in an overall car-light district. We desired to make our site sustainable by lowering the EUI in embodied energy than the average buildings in Chicago, reaching towards net zero operations. We also tried to maintain the diversity of areas by creating diverse neighborhoods and a diverse set of economic activity by hosting startups, innovation within the site. We also desired to make our site livable with many green areas and high walkability. Here's a street grid view of our proposed site with our proto-block layout. We did some of our analysis at the proto-block level, especially for energy, but in terms of walkability and connections to like the greater Chicago region, we looked at the entire region. And you'll see our ferry ports and expanding our buildings. So here is a bit more detail of our proto-block layouts, where you'll see bike paths, walking paths, green spaces, and a walkability flow. We also tried to maximize the views of our buildings and maintain a proper wind flow throughout the streets.
Thanks, Tessa. So for essentially our approach was to look at the proto-block level first, and then the site, which is a subset of the entire urban area, and we extrapolated it to the entire urban area, which because it has a much bigger space and it gives us a lot of opportunities to kind of play with the area. So one thing we thought interesting was to kind of use cross-laminated timber, which has pretty good carbon sequestration properties for the low-rise buildings. And this approach is similar to some of the more modern net zero energy building and also Sidewalk's proposal for Toronto waterfront. So this is how we envision for the prefabricated CLT panels to be brought on site and fixed on it. And next, we kind of explored the different proto-block shapes and sizes based on our FAR, based on the area and the GFA that we want. And we eventually settled on 2 kind of proto-block design. So the first kind of looks like this. It has green spaces interspersed with residential as well as retail blocks below. And we thought it would be interesting to kind of also, because we want it to be an innovation and startup space, to kind of also have data centers below and to see whether we can, in the winter time, do heat recovery, where we use the waste heat from the data center to heat the residential area, and in the summertime to use the Lake Michigan as a lake source heat sink for these data centers. So this is the second proto-block design, which essentially follows the same principles. They are walking paths along mini little community spaces and terraces, as well as residential tower blocks that go above. So I wouldn't be touching that much about our simulation templates and floor plan layouts, but for the residential, we have typical studios, 1 bedders, 2 bedders, and commercial, your typical meeting rooms, offices, and retail. So then we extrapolated what we have from the site onto the entire urban area and added in some additional features. So from the left, you can see these blocks, which are essentially main car parks, which also acts like a mini central parks. And this we have urban farm rooftops for that. We have a ferry terminal in the middle, and the main waterfront area where people will walk from the transport terminal to the ferry terminal. And then on the left and the right, you see these are 2 bigger car park facilities which have green spaces in the courtyard area and solar PV rooftops. So from a rendering fly-through perspective, this is a simple fly-through of how the entire urban area looks like. So this is the main ferry terminal where you can get the ferry and head to the main Chicago area. The main waterfront area, the orange blocks are retail, and the pink ones are offices, the transport terminal. And then head into, this is kind of like the mini, we call it the mini central park with urban farms at rooftop, and they will also act as car parks. And then on the right, this, we are using it as a PV solar farm on the rooftop, and the bottom are car parks. So then this is just some more information on the site itself. I won't go into detail, but feel free to ask us questions about that. So another thing that we realized that was interesting is that because this site is very big, it gives us opportunity to kind of give every residential tower block good views. So one thing that we realized that which was when we extrapolated the urban area across the entire South Chicago, there are many dense areas which kind of blocks the view. So we kind of did simple analysis in Grasshopper, and these lines are essentially just vector lines. And the mathematical objective function is simple, right? So the longer the lines, the better the views. So as you can see, my mouse cursor there, this area and this area are pretty dense. And so we kind of tweak the blocks while adhering to the floor area of the FAR and the gross floor area that we want to kind of give it a more seamless and a smoother urban fabric.
So to meet the planning goals that we established for our project, we decided to closely investigate daylight, energy consumption and supply, carbon emissions, transportation, local food production, and finance. So first we investigated daylight. We conducted parametric studies for different versions of our proto block design to establish what design we should favor. And we compared them to the existing building geometries in Chicago and chose two designs which were performing best in terms of the daylight access. And for our design of the proto block, a window-to-wall ratio of above even 30 to 40% performs significantly better than the typical Chicago building. Next slide, please. For the reasons I will explain in a minute, we have chosen a window-to-wall ratio of 60%. And on a neighborhood scale, this results in SDA of 64. Next, we decided to investigate the operational energy, as well as how we could manage the energy supply. So at first, we performed energy usage intensity parametric studies for both proto blocks, which we intended to use in our district. And by upgrading multiple parameters, many of which are equipment and lighting power densities, glazing, heating and cooling system set points, and efficiencies and construction materials, we were able to significantly decrease. I think. Sorry. Next slide. Next slide. We were able to significantly decrease the EUI by around a third, and I think the slides are a bit shifted. If you go to the previous slide, and by doing the parametric analysis of SDA versus EUI, we were able to find a sweet spot where the EUI is still pretty low, but we get a high SDA, and that's how we arrived with 60% of window-to-wall ratio. And next slide, please. So when performing the analysis for the entire neighborhood, the EUI of our design was 214 kilowatt-hour per square meter for the whole district. And additionally, while having a significant heating and cooling needs, we have also investigated how the energy use intensity would change over the years under the stabilization scenario. And according to the model, the EUI would increase until 2035, mainly due to the cooling. And then it would keep stabilizing around 2065 to then decrease by 2080. And the operational energy carbon emissions of a resident of our district would accumulate to around 76 tons of CO2 over 60 years.
My internet is a bit lagging, so please bear with me. So this is how we envision our district energy system to be. On the right, you can see that the main demand side comes from the residential, office, and retail, and on the left is the supply side. But I would like to bring our attention to the data center on the top middle, as well as the PV on the bottom left. So for the data center, how we envision is that it will act as a heat source for the residential buildings to heat them up, kind of use the waste heat to heat them up during winter. And during summertime, we will purge the heat using the Lake Michigan as a heat sink. And this is an interesting idea that has been explored in different countries, such as China. In Alibaba is one of Alibaba's data center, as well as countries like Finland and Copenhagen. So for the data center wise, we size them up using heuristics and some and pretty ballpark figures. So for the base blocks, we cater up to 6,500 meters square, and based on 3 meters square per server rack and average consumption between 7 kilowatt to 15 kilowatt, we just assume an allocation of 2,000 server racks, which is a pretty high capacity already. And so this is how we think that the typical server room system can be like. So server waste heat from servers actually is not significantly hot, right? Because it ranges from 25 to 50, but it's more commonly between just 28 to 35. So what we need is to essentially augment this with heat pumps to boost the heat to 70 to 80 degrees Celsius, which is sufficient for district heating purposes. And modern heat pumps for these purposes are pretty efficient because they have kind of like COPs of 3.8 all the way to 4.8 or even 5. So this is during winter time where we were use the waste heat. And for summertime wise, we are implementing the lake source cooling system, where it's kind of like a closed loop system where we will use the cold lake water pumped to the heat exchanger at the shore, and it will absorb the heat that's purged out onto the heat sink using Lake Michigan. And this will circulate around the buildings and data center to collect the heat removed from the air conditioning.
One of the elements of our energy supply are solar panels, and we have decided to place them in 2 different locations on our site. So first, we place them on the selected rooftops of the buildings, and with that, we are able to supply over 700 megawatt hour for each of our small neighborhoods. And second, we have also considered a bigger picture and looked at the whole site, and we propose to install PV panels on each of the 2 main car parks on both sides of the area. And in total, the car parks can provide over 5,000 megawatt hour with an average supply of 200 kilowatt hour per square meter per year. And this is then equally distributed across the whole site to each smaller neighborhood.
So to look at the energy impact of this is the monthly energy loads for one proto block. So we broke that down because simulation for the entire area simply took too long. And these are the monthly heat energy loads. And if you look at the PV energies that is supplied by the PV, these are in green. So the light green are the PRECINCT proto block. So you can see that they actually do not contribute that much energy anyhow. And the darker green one below here are the PV that's supplied by the larger photovoltaic farms at both sides of the PRECINCT. So they give slightly more, especially over the summertime. And on the image on the right, this is the waste heat where we hope to use to kind of reduce some of the heating loads during winter. And the energy supplied to the data center is constant over the years, and how we calculated this is just based on the PUE, the power usage effectiveness, times the coefficient, the COP of the heat pump. And as you can see, during the summertime, there is the additional cooling load because we can't use the heat during summertime, the additional cooling load which needs to be purged to the lake. And after taking away all this, we are not able to heat net zero energy, obviously, but we do manage to reduce the energy load rather significantly by about 33 to 35%. And so we also quickly look at UTCI and outdoor thermal comfort, mainly along the main waterfront area. So as you can see, during winter time in January, there's significant cold stress, and during summer, there's moderate heat stress. But apart from that, during spring and fall, it's pretty much okay, and it's just mild cold stress.
So Chicago.
Thank you, Qian, for perfectly setting the thermal outdoor comfort to lead us to talk about transportation and walkability. Starting from the macro scale, talking about the distances and times and the options we have to go in and out from our South Chicago to the Central Chicago. Fortunately, we already had transport terminal proposed for our site, but it would take 45 minutes to 1 hour for a person to go from our site to downtown, which is like almost twice the amount of time that a car would take for the same distance. And to promote our residents to use public transport instead, we developed ferry terminal, which would take as much time as the car, and we placed it at a location which was more preferable than the car parks which are designed to be at the either corner of our site. So as we can, as I've already told, the major car parks that we have are at the either corner of a site, but we also designed smaller 4 car parks which are central to the site, keeping in mind the harsh winters Chicago goes through. And talking about the car parks, we made sure that we cater to not only our initial site, but the entire neighborhood of South Chicago, and not just the population that resides there, but also the daytime population influx that the site may have, because it is a mixed-use site. Coming to the micro-scale mobility, we wanted to have a car-light neighborhood and to promote walking and more pedestrian-friendly neighborhood. And we kept our options open to bike sharing and electric scooter. Rather, we had a preference for it because it would reduce the time of walking from one destination to another by like a third of the times. And it is even more economical and usable to have shared resources with less cost. That was how we placed the physical transportation hubs throughout our walkability throughout our neighborhood. And now we talk about the social aspects of why we placed the central accesses the way we did. We wanted to have a central focus at the waterfront canal that we have, and we kind of focused more on that by creating the mixed use around it, and to create this vibrant neighborhood that can that the residents and the workers around the neighborhood can take advantage of. And we also, coming to the next slide, putting numbers on each one of those, incorporating ferry terminal, transport terminals, everything together. We can see we got a high score for biking as well as walkability. But to cater to what reduced it to not getting it to 100, we can see that the northern side of the canal is much more beneficial in the terms that it has closer proximity to our public transit than the southern side of our canal. And that is very much prominent by the colors, the yellowish tones that we have in the southern side. Moving on to food production.
Chicago is located in a cold urban climate with not much farmland around, and most of the vegetables traveling thousands of miles from Mexico or Central America before they reach the markets in the city. And we've estimated 7,500 tons of vegetables consumed in the greater sites per year, and $52 million spent on the vegetables. This really gives a potential to explore urban and local food production. So as Tessa mentioned, slide before. As Tessa mentioned, the neighborhood that we are considering is located in a lower income area with a significant unemployment. And one of our main goals is therefore to provide jobs to the local community. And additionally, urban farming in the context of our site allows for reducing carbon footprint of food while having a profitable business. And last but not least, we also aim to use farming and gathering as means of building a community and educating children. So for that, we design educational and community food gardens, which kind of resemble the incredible edible movement which originates from the UK, which we've greater community as well as school children can farm together for pleasure and educational purposes, and the food that grows is for sure. And next slide. So to create farming jobs, we have decided to place farms on the roofs of selected car parks, ferry terminal and transportation hub, as well as community food gardens near the South End car park. We have investigated different options to optimize for food production, carbon reduction, jobs creation, and profit. And with that, the total number of farms that we ended up with are basically, they could be built out of around 2,000 shipping containers, or in other words, they take around 60,000 square meter of area, which is otherwise unused. And with that, we have managed to achieve 35% of total veggie supply while saving 1,500 tons of CO2 and generating significant profit. And more importantly, we provide over 1,500 jobs for the local community.
We also did rough calculations of how long the payback period would be using monthly rents and average construction costs of the Chicago area. However, more research needs to be done of how specifically our building improvements will change the monthly rents and therefore the payback period for our buildings. So overall, our city proves to be sustainable, diverse, and livable with a high energy efficiency, reduced carbon dioxide emissions, a high walkability score, and substantial job creation. Thank you.